Hello, welcome back to my GCSE Chemistry. In this video we're going to be talking about atmospheric pollutants, how they're formed and what damage they can do. Atmospheric pollutants are substances that contaminate our air, making it harmful or damaging. Most of the pollutants that pollute our atmosphere are formed from the combustion of fuels in factories, power stations, in trucks, cars, etc. These pollutants include carbon dioxide, carbon monoxide, carbon particulates or particles, sulfur dioxide, nitrogen oxides, unburnt hydrocarbons, and water vapour. Some of these pollutants, such as water vapour and carbon dioxide, are already present in the atmosphere, but we class them as pollutants when they're in such a high concentration that they can cause damage or harm. The other pollutants, such as sulfur dioxide, carbon monoxide, and nitrogen oxides, aren't normally present in the air, and therefore their presence causes a problem. We'll look at how each one is formed and what specific problems each pollutant is associated with. First of all, we'll look at the combustion of alkanes, which produces carbon dioxide and water. These are formed when fuels such as petrol or diesel are burnt completely in the presence of oxygen. However, while both carbon dioxide and water are greenhouse gases and can cause damage, these two pollutants aren't toxic to humans, animals or plants, and therefore are much less of a danger than some of the other ones we're going to look at in a minute. If there isn't enough oxygen when fuels are burnt, which is more likely to happen when the hydrocarbons have a long chain length, then incomplete combustion occurs. Incomplete combustion can lead to the production of carbon monoxide, which is a toxic gas. It's colourless and odourless, so you can't tell when it's present, and it binds to the haemoglobin in red blood cells, taking the place of oxygen and therefore starving the body of oxygen, causing suffocation. In small quantities, carbon monoxide is relatively harmless, but if it builds up, such as in a garage or in a concentrated urban area, it can cause more severe problems. Another pollutant that can also be produced from incomplete combustion are carbon particulates, which are small particles of solid carbon. Sometimes this is referred to as soot. The presence of these small particles of carbon in the air can lead to something called global dimming, which is when the carbon particles in the atmosphere actually reflect some of the sunlight back out into space and therefore don't allow it all in. While this doesn't have significant impacts on things like global warming, it can have an impact on the production of plants because it will reduce the amount of light available for photosynthesis. Also, carbon particulates can damage the cells in our lungs and even cause cancer. Incomplete combustion can also lead to the release of unburnt hydrocarbons, which themselves can cause problems similar to the carbon particulates. So as far as possible, we want to avoid incomplete combustion when burning fossil fuels. So while diesel cars do have some of their advantages, the disadvantage is that it produces more harmful pollutants compared to shorter molecules like petrol. Now onto a pollutant that isn't directly produced from the combustion of hydrocarbons, but is a side reaction of the sulfur that's contained as impurities in many fuels. When the sulfur reacts with oxygen, it produces sulfur dioxide, which is an acidic gas. As sulfur dioxide builds up in the atmosphere, it dissolves in rainwater to form acid rain, which damages trees and harms wildlife, especially animals and plants that live in lakes where the acid rain can build up. Acid rain can also cause damage to buildings, particularly ones that are made out of limestone, which is calcium carbonate and therefore reacts with acid, and can even cause damage to metal buildings. However, there are ways to prevent or reduce this kind of pollution. Sulfur can be removed from fuels before burning it, as you might have seen in low-sulfur diesel. So in the case of fuels for cars, as much sulfur is removed from the fuel as possible before it's sent to the petrol stations. Alternatively, and as is often the case in factories and power stations, the acidic gas can be neutralised in the waste flue gases, which are the gases that are on their way out of the chimneys at factories and power stations. Sulfur dioxide can be neutralised by basic compounds such as calcium oxide or calcium hydroxide. And by neutralising the acid to produce salt and water, the waste gases coming out of the factories and power stations won't be as harmful. The final pollutant that we need to worry about are nitrogen oxides. Nitrogen oxides are formed from nitrogen and oxygen in the air. They don't normally react, as nitrogen is very unreactive. However, in car engines, very high temperatures can often be reached, and this causes the normally unreactive nitrogen to react with the oxygen in the air. The reaction can form a variety of different nitrogen oxides, which is why we show the symbol for nitrogen oxides as NO with a small x next to it. Examples of a nitrogen oxides might be nitrogen dioxide, dinitrogen oxide, or nitrogen trioxide. And it's common that a mixture of these gases are formed. All of these gases are toxic and acidic. When they build up in the air, especially in urban areas, they can cause breathing problems and worsen asthma and emphysema, which are breathing-related illnesses. And because nitrogen oxides are acidic, the production of nitrogen oxides can also lead to acid rain. So, here's a summary of the reactions we've gone through. They're all related to combustion of fuels. They might either be from directly combusting fuels or a byproduct or side reaction related to combusting fuels. Note that as well as the reactants listed on the right-hand side, unburnt hydrocarbons are also released in some of the incomplete combustion reactions, and these can cause their own problems. Here's a summary of what we looked at in the video. For each of the pollutants, it's important that you know where they come from and how they're formed, as well as what the main problem is associated with that pollutant. That's it for this video on atmospheric pollutants, and that's it for this topic on the atmosphere. If you've been enjoying these videos, please like us on social media. Thanks very much for listening, and I hope to see you again on the next topic about using resources.